Greetings. We are Ismail bin Samsudin, Kaushalia Dayalan, Tan K. Chin, Hasmawi bin Mat Yusuf and Zuraidawati binti Zulkifli, teachers from Sekolah Kebangsaan Ranto Panjang, Klang. We would like to present our project entitled Superhydrophobic Surface Test, integrating nanoscience concepts into primary STEM education through hands-on experiments. Nanoscience concepts are often perceived as abstract at the primary level. Our project demonstrates how hands-on experimentation with taro leaves, Colocasia esculenta, can make nanoscale phenomena observable, engaging, and accessible to young learners. There are several reasons taro leaves were selected for this study, including their natural water-repellent properties, which are similar to the well-known lotus effect. Their micro and nanoscale surface structure enables water droplets to bead up and roll off easily, making them an ideal real-world example of superhydrophobicity. Moreover, taro leaves are also safe, locally available, low cost, and require no specialized equipment, making them highly suitable for a primary school STEM activity. Their use allows pupils to observe nanoscale concepts through everyday natural materials, supporting inquiry-based learning while ensuring accessibility and sustainability. The problem statement of our project is, many primary school pupils struggle to understand nanoscale concepts due to abstract theory and lack of practical exposure. This limits their engagement in STEM education and early scientific curiosity. Among the objectives of this study are 1. Introduce nanoscience through observable experiments, 2. Foster inquiry-based STEM learning using the 5E instructional model, 3. Promote critical thinking and environmental awareness, and 4. Align educational innovation with SDG 4, quality education. We employed the 5E instructional model to conduct this study, which includes engage, explore, explain, elaborate, and evaluate. Firstly, during the engage stage, students explored water repellency on taro leaves. Next, during the explore stage, hands-on spraying experiments were conducted comparing taro leaves and ordinary paper. Then, during the explain stage, pupils discussed observations using scientific terminology such as contact angle, surface energy, and self-cleaning mechanisms. Broader applications in daily life and technology were discussed during the elaborate stage. And finally, during the evaluate stage, worksheets and rubric-based assessments captured student understanding and engagement. The results of this study can be explained in 3 ways. Firstly, students' performance. 85% of pupils accurately described water repellency after the activity. High-performing pupils scored up to 10 out of 10, whereas low-performing pupils needed guided prompts to explain concepts like contact angle. Next, conceptual understanding. Pupils successfully distinguished between superhydrophobic taro leaves and absorbent paper. Most pupils correctly linked the phenomenon to surface structure, contact angle, and surface energy. In terms of engagement and interest, pupils showed high curiosity when observing real-life nanoscale phenomena, and teachers reported increased participation during discussions. This study shows that taro leaves made nanoscience concepts tangible, illustrating the lotus effect and micro-nanostructures. At the same time, the 5E model effectively engaged pupils in hands-on inquiry, supported use of scientific terms, connected concepts to daily life, and promoted strong understanding, with some learners needing additional support. Finally, this study ensures that low-cost, safe materials allowed meaningful STEM learning without lab equipment. This supports SDG 4, quality education, by promoting accessible, inquiry-based science learning and building early scientific thinking. The benefits of the superhydrophobic surface test included safety, low cost and accessibility as a method for conducting the teaching and learning process. From this method, pupils too could observe the nanoscale effects in everyday objects. Moreover, this method fosters early STEM interest and critical thinking among students, while also supporting inclusive, high-quality education aligned with SDG 4. The future potential of this approach is that it can be integrated into sustainable STEM modules in schools. The experiment is low-cost and scalable, offering potential for broader adoption, teacher training programs, and curriculum enrichment. In conclusion, the superhydrophobic surface test effectively introduces nanoscience to primary pupils, fostering curiosity, inquiry, and critical thinking, while promoting high-quality STEM education in line with SDG 4. This concludes our presentation. Thank you for your attention, and I hope